Hi, this is Sir Aris. Let's talk about solutions of some differential equations. So let's consider an example where you have an equation given describing the interaction of populations of field mice and owls, so certain creatures. Find the solutions of these equations. So we can write the equation in this form. dp by dt equals p minus 900 over 2. And as long as p is not equal to 900, then we write dp divided by p minus 900 equals dt over t. And then we can integrate both sides. So when we integrate both sides, this left side becomes ln of p minus 900. We use an absolute value. So in our notation, we put absolute value. You don't have to, but you just have to be consistent. Okay, so here we assume that p may have values that are less than 900. So c, or the right side is t over 2 plus c, where c is an arbitrary constant. So taking the exponential of both sides, we have absolute value of p minus 900 equals e to the power of t over 2 plus c. Okay, we can write e to the power of c times e to the power of t over 2. Removing the absolute value, this becomes p minus 900 equals plus minus ec times et over 2. And finally, we can write p as 900 plus c, small letter c, e to the power of t over 2, where small letter c is plus minus e to the power of c. This is an arbitrary constant. So if you make a plot of the solution, plot of p versus t, this is for several values of c, small letter c. I think I used values 90, 60, 30, 0. So 90 would be, so if it slopes up, it's 90, 60, 30, 0, the negative 30, negative 60, and negative 90. So we actually have infinitely many solutions because we can assign many values of c. Our focus is to find a single solution by specifying c. We can do that by specifying a point that must lie on the graph of the solution. For example, we could write that p have a given value at a certain time. For example, if p is 850 at time t equals 0, or expressed as p at 0 is 850, we can substitute that and get p equals 900 plus cet over 2. T is 0, p is 850, so we get c equal to negative 50. This additional condition that we use to determine c is an example of an initial condition. So that this equation, differential equation, and this condition form an initial value problem. So given a general equation like this and an initial condition, so we're writing this in this way. Integrating both sides, we get ln of y minus b over a equals at plus c, exponentiating, and then setting the c as our arbitrary variable. We can get, and also using our initial condition, so that c becomes, if we set at time t equals 0, this becomes this ea0 is 1, y is y naught. So that gives us c being equal to y naught minus b over a. So that the solution can be written as y equals b over a plus y naught minus b over a times e to the power of at. For as long as a not equal to 0, this expression is called the general solution. And if we create a graph, the graph is an infinite family of curves called integral curves, where each integral curve is associated with the value of C and the graph of the solution corresponding to that value of C.